Okay, notice these are not in order. So take a moment and take your drawing tool and figure out which one goes with which, because you can see the product property. There's no product there. If I look at my exponential version, I'm looking for addition. So that doesn't go there, it goes here. Figure out the other two. And then check up here when you're done. So the only one that's kind of slightly different is the power property. Because what the power property says is, I'm going to take my exponent and move it in front of the logarithm, thus the p being right here. Okay? So I multiply my exponent times my logarithm. It's taking the logarithm of this term to that power. Okay? The other two are exactly as you've seen in the exponent rules, except it's a reverse. Before, we took two bases and converted into one base by addition. In this case, we take the two logarithms and make it into a single logarithm by product. So it's the reverse of your exponent rules, but it's the same rule. So without further ado, let's just practice a little bit, and then we're going to start solving equations with it. All right, so two things are going on. I need to move my numbers in front using the power rule. So it's going to become an exponent here and here. So we're trying to make a single logarithmic expression, because yesterday when we learned how to solve them, we could only do it when we have a single logarithm on both sides. So right now I got two, I need to make one. So in order to do that, my first step is to move the numbers in front instead of coefficients to make them exponents.
Attention, this is Assistant Principal Mr. Lattimore. At this time, we are initiating a shelter-in-place. Please follow the shelter-in-place procedures.
Shelter-in-place procedure means we stay in the room and we just keep doing things as we normally do them.
Attention, this is Mr. Lattimore.
Hello, Mr. Lattimore.
At this time, we are initiating a shelter-in-place. Please follow the shelter-in-place procedures.
Okay, got it. So log base 9 of b 2 to 6. All right. Do I have one logarithm yet? No. So I'm going to utilize my quotient property. My quotient property says I'm going to change my subtraction into a division problem with a single logarithm. So here, I've got my exponent rule. It goes in the other direction. Okay, so we're reversing it. So where we had changed into 1 by subtraction, here we're going to change it into 1 by division. So you could do a little Control A, Control C, Control V action. And then get rid of the first logarithm. And I want to divide the u to the 24th. If I hit division now, look what happens. Oh no! So I just want to divide the u to the 24th. So just select that piece, division. And I want to cut instead of copy. So Control X. And go down that little gray box. That's it, done. So I made a single logarithmic expression, which I can now use to solve logarithms, and we'll do that in a couple minutes. So taking that into account, see what you can do with the other two on your own. So the one on the right would use quotient rule, and the one here would use a product rule. Okay, so take a few moments, see what you can do on your own. Addition is going to utilize multiplication. Okay, so here we go. Change this one. Got to move the 3. So still log base 7. And all of these logarithmic properties only work if the bases are the same. What happens if they're different? We'll get to this a little bit later. Okay, plus log base 7 of y to the 12th. Okay, so all I did was move the 3 and the 12 to the respective variables and make them exponents. That's it. Second step, and this is the one that is changing it into our single logarithm, what we're trying to do here. Log base 7 of x cubed times. So we're using the product rule, which says if I have two separate logarithms, I can write it as a single logarithm and make a multiplication. That's it. So we've accomplished our task of expressing these separate logarithms as a single logarithmic expression. The first one is more like the third one is more like the first one. So log base 3 of x cubed minus log base 3 of y to the 5th power. And then, just like the first one, instead of multiplication, this one's division. Log base 3. Now watch what I do here. Another way I can take care of this, instead of highlighting my x cubed, is put everything in parentheses. If I put my x cubed in parentheses, then I can just divide it by my y to the 5th. Okay. So again, this is going to make a little bit more sense when we start solving equations. Right now, this is the wax on, wax off purpose. Okay? So we're changing single logarithm because yesterday when we solved logarithmic equations, we could only solve them if there was a single logarithm on both sides. So if you remember that, great. If you don't, well, it'll come back to you in a few minutes when we start solving them. All right. This one is doing it in reverse. We're expanding. So we're not going to have a single logarithm. We are going to have multiple logarithms. However many variables you have is how many logarithms you've got. So in the first one, I got 2, so I'm going to make it into 2 logarithms. Second one, I got 3, so 3 logarithms. On the last one, I got 2, so I'm going to have 2 logarithms. I'm going to do the first one and the third one 2 different ways. You can decide which way you like better. The end result is going to be the same. Okay. First step. Hello, Ahmad. Perfect. Just put it on my desk. Is that from a teacher? Okay, so, oh, that's from Sweet. Okay, then I don't have to worry about it. Cool. First step. That's 5. Before we put it on the exponent, we're doing this in reverse. So it is now going in front of the logarithm. So 5, logarithm of base 4. Everything else is going to stay the same. X to the 3rd divided by y. Okay. Step number 1. Step number 2. We're now going to expand it into multiple logarithms. So I'm going to do Control A, Control C, go down here, Control V, and I'd move it a little bit to the left because it's going to get a little longer. We're going to change our quotient. So our quotient rule says if I want to expand it, I change division to subtraction. So beep up right here. And since I'm going to be sharing that 5 with multiple logarithms, I'm going to make a little bracket here. Okay. Ooh, not brace. Now I'm going to make parentheses because we don't need this parentheses anymore. So minus log base 4 of y. Question so far? I still don't get it. I don't understand. I want to cry in my cereal. Okay.
Your cereal?
You ever cried in your cereal? Oh, it hurts. It's bad. It makes it all salty.
Cereal's my favorite.
All right. Hey, remember that first exponent? We got another one. Guess where? Moves to the front, but only the front of the log that is attached to, not to the 5 all the way in the front. So, little Control A, Control C, Control V. Come on now. Paste. Only thing that's happening, I'm changing for the 3 here. One more step. If I've got parentheses and I don't want parentheses, what I got to do with the 5?
Good.
Distribute. Okay? So one more time. We'll do a Control A, Control C, Control V. We're going to get rid of the parentheses. And we're going to do the multiplication. So 5 times 3 is 15. And then 5. Okay? This used to be real useful back in the olden days before computers because people had to compute really big numbers. What's easier? Multiplication and exponents or multiplication and subtraction? Subtraction. You don't have a calculator and you have to figure out what, I don't know, 1.06 to the 12th power is. Yeah, you can't do that. Okay? Not in any timely fashion. So logarithms were really useful prior to computers. All right. Ready? Second one. See if you can do that on your own. This one's a little easier because the exponent's on the inside. So split it up. Your final answer should have 3 different logarithms and no exponents. Then there's not going to be any subtraction. Okay? So log base 8 of A plus log base 8 of B plus log base 8 of C to the 6th power. But the 6 is going to be put in front, so I do a little Control A, Control C, Control V, take the 6 up here, bye-bye, and put it in front of the logarithm, okay? Back when I was your age, we actually had to do, teacher would give us like really big numbers, like 3,600,000,000 times
1.
no, times 4,700,000,436,000,000, and we had to use these big numbers, and then we used logarithms, changed it into smaller numbers, and then did something called the anti-log.
I only know one big number. 6.022 times 10 to the power of 23.
Avogadro's number.
Yeah.
I'm the son of a chemist, so it was never past the salt. It was past the sodium chloride. Log base 4. Okay, ready? Instead of moving the 5 first, we're going to use the power rule for exponents. So take that 5 and distribute it. Oopsies. Nope, all right. Take the 5 and distribute it to the A and to the B to the 4th power. So that means this is A to the 5th power. And 4 times 5 is 20. At this point, I'm going to split it up into 2 separate parts. I have 2 logarithms. Oh, let's use a different color so we don't get mixed in with the other ones. So log base 4 of A to the 5th. And it did not change colors there. Plus log base 4 of B to the 20th. And last but not least, we're going to take that, whoopsies, on up here, B to the 20th, Control A, Control C. Final answer, no exponents. Okay. So when you see multiple choice tests, do you think sometimes they might throw some exponents in there? And that's going to be, it's not going to be wrong, but it's not the final answer. So you need to be careful about that. So the 20 goes in front of the second one, and the 5 goes in front of the first one. Okay. So notice, the first one had subtraction because it was a division problem. The last 2 had addition because those were both products. Okay. Got to know the names. If you don't know, look up at the board. Product means answer to multiplication, and quotient is the answer to a division problem. But you are sophomores and juniors in high school, and you should really know what a product and a quotient is.
Oh, that's easy.
All right. Time to use them to solve. Okay, you can use the properties to solve the equations involving logarithms. I can't solve my equation until I have a single logarithm on both sides. Good news is these only have one log on one side, so I'm going to leave that one alone. So right hand side, leave it alone. So equals log base 6 of 54. Okay. Left hand side, I'm going to use my product property to make it a single logarithm. Log base 6. So what am I doing with my x and my 6? 6 plus x? 6 divided by x? 6 times x, or x times 6. We usually write the coefficient on the left, so we're going to write 6x. Okay? We talked about this yesterday. Now that we have the logarithms all by themselves, we're going to take the antilog. Back in my day, they'd actually make us write out the word antilog in front of each one of these. I'm not going to make you do that. You just understand that when I have a single logarithm with the same base, these are both 6s, I take the antilog means I can pull them apart. And now this is a middle school math problem. 6 times what number is 54? Don't say it, just write it.
What do you mean? Yeah. It gives me.
Yeah, it's pretty much just for you, Noah.
Yeah, you get things.
You know.
Yeah.
Okay. When you have your answer, we should
Check
check it. So, go to Desmos. Type in log base 6 of 54. Let's see if this makes sense. 6 to the first power is 6. 6 to the second power is 36. So 6 to what power is 54? Something a little bit bigger than 2, like 2.226. Blah, 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 blah. All right. We have log 9 base 6 and log 6 base 6. So log base 6 of 9, which is 1. Hey, wow, I'm only 1 away. LOG, because what's log 6 base 6? 1. So it works. Okay. You don't always have to do it in Desmos, but I would recommend it until you're really comfortable. I'm going to show you some shortcuts where you don't have to use Desmos. You okay, Adrian? All right. So try the one on the right on your own. You're going to need to use 2 different properties, but you need a single logarithmic expression in order to do it. Your first step is to move that 2 back up to the top and use the power rule. So if you did not make that 6 squared, then everything else after that is going to be incorrect. Log underscore 3, 6 squared. Everything else stays exactly the same. Minus log underscore 3 of w, not u, w, equals log base 3 of 6. Okay? Change my subtraction of 2 logarithms into division of 1 logarithm. So, and change my 6 squared to 36. So I am going to put this in parentheses. You don't have to. I think it works quicker for me anyway. Once I have a single logarithm on both sides, I can remove the logarithms. I take the anti-log. And now it's just 36 over w equals 6. Okay? So I will do it the official algebra way, but you can kind of think, hey, what do I divide 36 by to get 6? Shh. Okay? But the official algebraic way would be to multiply both sides by w. The w is divide out on the left, and I got 36 equals 6w. So w equals 6. So you could have just said, hey, I know that 6 goes into 36 6 times. Check, check. Okay, I'm not going to check this on Desmos. I'm going to check it right below here. Use a little common sense. Here we go. I got 2 log 3 base 6, and I put the 6 in for w. I have 2 of something minus 1 of something. If I have 2 of something minus 1 of something, how many of those somethings do I have left? So that means I have log base 3 of 6. Hey, what's on the other side? Log base 3 of 6. I don't need Desmos. Okay? So you don't always need Desmos to work out. It doesn't work all the time. Sometimes you're going to have to go to Desmos. All right. Ooh. Pretty. Try that one.
That's not pretty. Pretty's like.
I think all math working hard together. That's called sarcasm. All right. LOG underscore 2 of x to the 4th power. Ooh, wait. If I have x to the 4th power, how many answers am I going to get? I'm going to get 4. How many of those answers are we going to be able to use? Let's find out together. Equals LOG underscore 2 of 125. Okay. So, we used the power rule. Now we're going to use the quotient rule. So Control A, Control C, Control V, and left hand side. Going to come over here, put in some parentheses. You know, Cammy's not so smart. Whenever you put a left parenthesis in, Cammy's going to put it all the way in the end, so we need to tell her, okay, And she's not AI, so she's not going to remember. She's going to do it every single time. Okay? So see if you can do the rest and find all 4 of your answers. I undo division with multiplication. Oh, look. That's not what I wanted. 5 times 25 is 125, and 5 times 100 is 100 or 500. So 500 plus 125 is 625. Okay. So I am now going to take the 4th root of both sides. When I take the 4th root of both sides, most of you have figured out 2 of the answers. I'll see if anybody can figure out the last 2. So x was equal to plus or minus 5. Where are my other 2? What was the new number you learned last semester? Last semester.
Imaginary.
So, of those 4, how many can we use? 1, just a positive 5. So my final answer here, so I get rid of the negative here. I get rid of imaginaries because I can't take logarithms of imaginary numbers. And I'm just going to make this look a little prettier. Final answer is x equals 5. Okay. All right, just like before, I don't need to work this out on Desmos because we just said we put 5 in here. So log base 2 of 5 to the 4th minus log base 2 of 5. We're going to see if that's equal to log base 2 of 25. Well, 5 to the 4th. Oh, wait, can I change my logarithms from 2 into 1? And what do? I take my 5 to the 4th and divide it by my 5. Remember, this is really just 5 to the 1st. 4 minus 1 is 3. Is 5 to the 3rd the same as 125? Could you do this as easily in Desmos? That's fine. I don't care how you check it, but you really want to make the time to check your answers. Okay. So 5 works. Try that one. You're only going to have 2 answers this time. Do you think you should check both of them? Yes. Doesn't even exist anymore. All right, here we go. Log base 4 of x times x minus 6. Use the product property. I cannot solve logarithm with logarithm on one side until I change it to exponential. X times x is x squared. X times 6 is 6x. I can't solve quadratics like this until it's equal to 0. So I am going to subtract 4 squared from both sides and simplify what 4 squared actually is, which is just 16. So 0 equals x squared minus 6x. And we move that 4 squared, which is 16, to the other side. And now this is a factorable quadratic equation. 2 numbers are multiplied to be negative 16 and add to be negative 6. Find them and find your solutions and check your solutions. 6, 8 and 2, but one of them has to be negative. 8 is negative because the 6 is negative. So x minus 8, x plus 2. But remember, it's what makes the factor equal to 0. What do I add to positive 2 to get to 0? Negative 2. So I get x equals negative 2 is one answer. What do I subtract 8 from to get to 0? 8. Okay. Okay, with just a little bit of thought. And remembering, I can't take logs of negatives. So this one doesn't work. And if I put an 8 in here. So log base 4 of 8 plus log 8 minus 6 base 4. Well, that's log base 4 of 8 times 2. What's 8 times 2? 16. 4 to what power is 16? Hey, look, right there. So this one works, the other one does not. Okay.
guys say something about me? You guys say something about me?
Yeah, we might come back to it. All right, take a look at this one.
Whoa.
So we haven't seen ones like this before, have we? So whenever we've done problems like this, one number is a power of the other number. Is 20 a power of 12? So what are we going to use to solve this? Whole unit's called logarithms. Most of the time, in classes before the 21st century, you couldn't take a log of any other base besides 10 and e. Can we take a different base now? 12. Yeah. Why not 20? No. Where's the variable? With the 12. So wherever the variable is attached to, that's when you're going to take the base up. Okay? Here we go. LOG base 12 of 12 to the power of x minus 1. Whatever I do to one side, so LOG base 12 of 20. I chose 12 because it's where the variable is attached to. You don't have to, but when you choose any other base besides this one, the answer is going to look a little bit more complicated because I'm going to have multiple logarithms.
So if my base was 6, I could put 6.
Exactly. Okay. You can use any base you want. Okay. Change of base formula says I could use 10, I could use e, but I'm using 12, and you'll see why in a minute. Because it's going to make less work for you at the end. Because what do we end up having to do at some point?
Make sure they're both the same.
If it's rounding to 10,000ths, one is they have to be the same base, and two, I'm going to need decimals. Okay? Because, hey Denise, do you know what 12 to what power equals 20? Yeah, me neither. Okay? I know it's bigger than 1.
Yep.
All right. Where does the x minus 1 go? Power property says put it in the front. Since it's together, we want to group them. What symbol should we use? All right. LOG base 12 of 12, and the right-hand side doesn't change at all, equals LOG base 12 of 20. Well, we've already talked. We already did log 6 base 6. We did log 2 base 2. What's log 12 base 12? 1. Okay. So in mathematics, frequently, we're going to do this. Put a little arrow and what it actually equals to. So log 12 base 12 is 1. What's 1 times x minus 1? X minus 1. 1 times anything is itself. X minus 1 equals log. And what's confusing is you're not used to seeing a logarithm. It's just a number. If this was x minus 1 equals 5, how would I solve it? How do I solve x minus 1 equals 5? Add 1. How do I solve x minus 1 equals log base 12 of 20? Add 1. It's the same process. Okay? And it's going to look weird, but this is the answer. Now, I don't care how you write it, but here's where you need to be careful. Here is a common, oopsies, not plus plus. Okay? Here's a common mistake that people make. And guess what? On a multiple choice test, this will be one of the choices. Ready? Oh, my answer is just log base 12, because 20 plus 1 is 21.
You sound like what's his name from what's it called?
Can you add the 1 to the 21? No, because it's not 20. It's log base 12 of 20, which is like 1 point something. Okay? So, yeah. So what I usually do is I put the 1 plus in front. Okay? Am I done yet? We got a round. So we're going to take this part and dump it into Desmos. So 1 plus log base 12 of 20. Little copy. Little paste. How many decimal places should we grab? We should grab 5 and then round it in Cami. Okay? So 1 plus log, because remember I told you 12 to 1 point something is 20? So if I add 1 to it, wouldn't it be 2 point something? All right, so if I grab 5 decimal places, whoopsies, hello. There we go. Copy. I'm going to put my little squiggly, showing my answer is not exact. And then paste. For some reason it's got dollar. Get rid of that. 2.0, so 2.20557 becomes 2.2056, or 2,056 10,000s. Okay, this one when you check, the check needs to be done in Desmos if you're going to do it. Okay, so let's just do this in Desmos. Okay, so I'm going to grab that 2.2056 and copy it back. So 12 to the power of. Hey, do you remember how that doesn't work so good in Desmos, but it works fine here? So I'm going to do it in Kimi. Paste, -1, and then Control-A, Control-C. This is why I don't have to worry about the making parentheses and stuff. That's pretty close to 20. Only off by 1,000. If I want to make this exact, what I can do is if I put in all these numbers, watch what happens. It's going to get closer and closer to 20 and get more and more zeros. So change that 5, 5, 7, 1, 3, 5. Okay, still about 1,000th away. 3, 6, 8.
You get an extra 5.
Extra 5. Oops. Back here. Hey, look at that. Okay. So if you go like, I don't believe it works, then just use the whole decimal check. I don't care. Pythons. All right. So we're done.